Hi everyone, and welcome back to Ask Confluent, where we discuss questions from the internet. As usual, I'm your host, Gwen Shapira, and with me today we have Guozhang Wang, who is the tech lead for the Kafka Streams team, and one of the earliest employees in Confluent. I think you were here before me, so that must
yes,
make
I
you...
think I'm number 10 or 11. You were number 12.
Yeah, I think
Yeah.
so. So I probably joined immediately after.
Yeah,
Yes, amazing. So we've both been here for a while.
very long time. Yeah.
Anyway, Guozhang is here not to talk about how awesome it is to work for 3 years at Confluent, but to talk about a little known but very important feature of Kafka Streams and then help us answer some more questions. So let's move for the first question. And it was written as a response to the previous Ask Confluent. And Matthias was on Ask Confluent to discuss some of the questions related to rebalancing and how that works in Kafka Streams.
Yeah.
And then as a kind of a side note, he mentioned that things work better when you have standby tasks. But he didn't really explain that much about standby tasks. So our listener Nova Le Pourquoi, and I'm probably butchering the name completely. It's French is not something that I'm that familiar. It sounds French. First of all, he or she says that they are a fan of my laugh, which probably makes them not just number one fan, but the only one. So thank you, I appreciate. And then the question, do you think it is possible to explain how standby replicas work in Kafka Stream applications? For dummies, please. So we have to start at the beginning.
Yeah.
The fact you need n instances plus one if you have just one standby replica, what does that mean? That other extra instances of the app need to be running on the same host. That extra standby app instances will take the work of failed crashed app within the same consumer group or app idea. Sorry for the long question. So yeah, that's a lot of question, but let's really start in the beginning. What are the standby tasks?
I think, actually, before we talk about the standby tasks, we can actually take one step back.
Okay, yeah.
And talk about how Kafka Streams achieve, data persistency even under a failover case.
Yes.
We know that Kafka Stream is for stream processing. And in stream processing, you will have states when you do stateful operations like joins and aggregations.
Yes.
And those states will be stored by default under the local, store engines of your instances.
And we mostly use RocksDB.
Yes.
Yeah.
And when those instances get either shut down or they have been crashed, right? Kafka Streams use the so-called changelog topics to basically bootstrap the state on a new instance.
Yep.
So that's how Kafka Stream generally works for high availability.
Yes, and this can take some time because we have a bunch of states to
Yes.
read and recreate.
Exactly.
Yeah.
So although the changelog topics is, it's stored in a specialized Kafka topic and it's log compacted, still sometimes when you are bootstrapping from the beginning of the changelog to the end of the log, it can take some time. Sometimes even in minutes.
Yes.
In our production use cases.
And while this is happening, basically the entire application is waiting, right? I mean, or we continue processing other partition.
For that specific stream task, yes.
That specific stream task
will
is paused, which means that there are some partitions that are not getting processed.
Yes, exactly.
Yes.
And give an example, if you are running interactive queries on that, if you query the state stores on that, restoring instance, you will get an exception saying it's not ready yet. Please come back later. And the user
and that
have
can
to
be for a
back
few
off.
minutes, which sometimes is not really what you
Exactly.
want. Yes.
Yeah.
Okay.
So the standby tasks is basically, proposed to remedy this issue. The mechanism of standby tasks is actually similar to what, replica in Kafka brokers works, if you think about it in that way. Today, we have a config named number of standby replicas under Kafka Streams. By default, it's 0. Means that we will not start with any standby replicas. But if you configure it to more than 0, say 1, then for each task, it will have that specified number of standbys.
So it's for each task. So if
For
I
each task.
specify one standby replica,
Yeah.
it means that, and I have, let's say, 4 partitions originally, then I'll have 4 tasks and 4 standby tasks.
Exactly.
Okay, that's important because when he talked about n instances plus 1, it's not
Yeah.
really n instance plus
Yeah, it's
1.
not-
You
it's
need
not.
2 n instances, really.
Well, you don't necessarily need 2 n instances because the way we allocate the standby replicas is the same as like we do that in Kafka brokers, where let's say if you have 4 active tasks and you have 4 instances, right? The active tasks will be allocated evenly into those 4 instances, and then the standby replicas can also be assigned to those instances, but we make sure that the standbys and the active tasks are never going to be assigned to the same instance.
Okay, so basically the instance is going to be busier because it has the standby and the main task, but it doesn't necessarily mean that I need more instances.
Yes. Yeah.
Cool. So the best way to determine if I need more instances or not would be just by trial and error, I guess.
Yeah.
Yeah.
Yeah. But we also have enough metrics at the task level so that you can see if, by adding replicas, standby replicas to your instances, if you are basically taking too much resources, especially for the CPUs, for the, disks, and for the memory itself.
Interesting. So which metrics do you think we should watch?
I think the number 1 metrics you should watch is the per thread metrics. So under, Confluent docs as well as Apache docs, we have a section of monitoring for Kafka streams, where we actually list all the metrics that, as a user, you should be able to, monitor on.
Yeah.
And among those, the higher level ones, which are, thread level metrics, is turned on by default. It's basically info level metrics. So those ones will tell you, like, if, for example, a specific Kafka stream, a stream thread, which is hosting multiple active and standby tasks, is already being overwhelmed.
Got it. So it says, for example, utilization of the thread, something like that.
Yes.
Oh, fantastic. Yes, that's exactly what I would want to watch. So, not sure we actually explained what do standby tasks do.
Right. So in terms of implementation, I want to give like a high level description of that.
Yeah.
So if let's say 1 or more standby tasks is assigned to a instance, they will basically share the same consumer they will share the same restore consumer that thread is using for basically continuously pulling the data from the corresponding changelog topics. For example, if you have an active task, which have, say, store number 1 and number 2, and each one of them will basically be writing into the corresponding changelog number 1, number 2, right? Then your standby task will basically be continuously fetching from those 2 changelog topics and building the state stores locally. So under normal practice, the state stores on the standby tasks should be very close to the state stores that you are running on the active task, because all they are doing is to reading from the changelogs that the active task is appending to, and then rebuild local state.
Okay, and then if the main task, the instance that the main task is on crashes or stopped, then what happens next?
So when the task migration happens, generally speaking, Kafka streams will basically prefer to allocate those migrating tasks into those instances which are already hosting the standby task in the previous run. Right?
Okay, so our rebalance is aware that, hey, we have a standby.
Exactly.
And then it will still have to do a bit of work to recover the standby.
Yes, but that will be much shorter compared with bootstrapping with 0. Or more specifically, for each state store, for both standby and active tasks, we actually do remember the checkpoint, which basically is the offset corresponding to the image of the local state. So when you are basically restarting from a standby task, and then that standby task presumably should be very close to the active task state stores, then you should see that the gap between the checkpoint to the log and offset of the changelog is very close.
Yes.
And we actually also provide a restore listener for users, so that listener can be triggered whenever the restoration happens, and when a batch of records has been fetched and applied to restore the state, and as well as when the restoration ends, when we reach the log and offset. So users can actually see from which point that you are restoring, let's say 100, And then you see at 120, which is the log n offset, you have finished the restoration.
Okay, that sounds useful. So I can actually know how long it takes and kind of optimize it around that.
Yes, and how many records you really have been restored from the change log.
Yeah, cool. So the next one is a response for the video on installing and running KSQL, which is part of the Level Up Your KSQL series. And Ultra Delta, which is, by the way, a fantastic name, says, I deployed Confluent on AWS server. Excellent choice, sir. And I want to use KSQL UI or dashboard. How do I do that? So that kind of depends what you mean by I deployed Confluent. But if you deployed Confluent Enterprise, it should arrive with Confluent Control Center. So when you do Confluent start on the CLI, it will spin up a Confluent Control Center. It will spin up KSQL server. And basically by doing HTTP to port 9092, you should be able to connect to Confluent Control Center. Scroll down a bit on the left side. There will be KSQL UI waiting for you. I think you need Confluent Enterprise version 5.0 and up. So the only caveat here is that the UI is part of Confluent Enterprise, means that you need a license. So you get 30 days free trial for you to try and see how it works. And then basically you need to contact us and we'll figure out how you get a license to continue. And we have a bunch of options. So just try it out. If it works for you, if you like it, ping us on how to get the extra, how to continue using it past the 30 days. Next question is, it's actually an oldie. I found few older ones that we never responded to on Twitter, so I figured I'll pull them in. This one from Vladimir Bukhtoyarov. I think I got it.
Yeah.
And he says, why do not extend deserialize method with headers? And he points to our GitHub repository, and he actually points to an older commit on the deserialize implementation. And he says, sometimes headers can be useful to make decisions to choose the proper serialization mechanism. For example, when migration from XML to any binary format. Yeah. So first of all, I love the idea that if I'm doing a migration from XML to Avro, I can actually use the header to specify which deserializer to use. I didn't think of it, and it's cool. And then it's interesting because the question was asked in September, and quite a lot of changed since, right?
Yeah. Yes. So actually, in 2.1, in AK and also Confluent Platform 5.1, we have a new feature that is I forgot the exact cape name, but the feature is that we actually are consolidating the extended serializer and deserializer into the existing deserializer classes.
Yeah, but since it's already in 2.1, we don't need the keep number. We need, you just download it and you use the deserialize API and the feature will be there.
When you are calling the serialize or deserialize, you should see the parameter headers in that already.
And I looked at the implementation and the Java docs, and it seems you use it just the way you use key and value deserializer. So it was fairly straightforward. But then when Vladimir asked the question in September, we actually had, like, if you're not up to date on 2.1, which admittedly is kind of new, you still use the older extended
serializer.
Yeah, so I was thinking maybe Vladimir just missed the fact because we put the deserializer in a different class, it's not trivial to know I'm using the serializer, how do I even find a different class?
And that's exactly why we consider to consolidate them into the same class.
Yes, and the reason we had it in a different class previously and we could move it into its own, into a similar class now, was basically due to some kind of Java compatibility feature, right?
That's right.
Yeah, so anyway, we stopped supporting Java 7 and we started, we can now, I know, right? It's about darn time. And we started, in 2.1, we have we merged the APIs. Remember that you can use the new Kafka client without upgrading the broker. So you can actually start using the new client and in the new deserializer with the much easier to find and use APIs whenever you feel like you're ready to upgrade dependency on your client, which is you don't have to ask permission from your ops guys, which I think usually makes things go a bit faster. And then maybe just thank you for I think the guy who did the consolidation of the APIs is Victor Smoigoi, I think, from Cloudera. And he does a lot of great work for Kafka. So thank you. We appreciate Victor. And on to the next question. Julian Bidou, also from the sorry we're late answering your question department. We're using Kafka and Avro to fill our relational database, Postgres. And we have the data model where we have one topic to one table. Due to async, sometimes a child is received before its father. And remember, it's the child and the father is two different tables, which means it's two different topics. From now, we made replay mode in order to wait for the father. So we kind of receive the child, we try to insert it, we see that we have a dependency issue. So we basically, I guess, kind of pause one of the topics and continue reading from the other topic until we get the related event. And then we start to insert them together, which is one way to do it. I think the other solutions that I would think of, we're basically looking at ordering. And Kafka does have strong order guarantees. You need things to happen in a certain order, and Kafka could do it for you as long as all the events go into the same partition.
Yep.
Now, the way to get events into the same partition is, first of all, get them into the same topic. Now, it used to be that you would never even think about events that go to different tables would have totally different structure, totally different schema. It used to be that you would never put them in the same topic. But there was a really good paper by, I want to say Martin Kleppmann, but probably either him or Chris Rucomini, maybe Chris Rucomini, on a blog. And look up on a blog. Basically, it's we'll have the URL down here for easy finding. And the idea is that you can actually, there are good reasons to put events with totally different schema on the same topic. And one of the good reasons is exactly when you need to guarantee order between different events. And it can be the problem you described, or, for example, if I open a bank account, then create account and deposit money would be very different events, but I need them to happen in the correct order in order to have a good bank. So you want, and we actually extended the schema registry to support this kind of use case when you have different types of events on the same topic. So you want to make sure that they go to the same topic, but that's not enough. You need them on the same partition. So you need a good key, select a good key to make sure they end up in a good partition. And in this case, you have the perfect solution in the relational database, which is the foreign key that generates a dependency in the parent-child relationship. So I would try for that as a data model before I would do the whole pause the reading of one topic and start reading from the other.
Yeah. Actually, in this year's Kafka Summit San Francisco, there are quite a lot of talks from the pipeline track, I think, that actually talk about exactly the the same issue, and the different speakers have a slightly different approaches tackling this issue. So I would definitely recommend, check them out.
Yeah.
And
Was there any talks that you remember as particularly engaging?
Yeah, I think there is like one from New York Times who have this issue.
Amazing.
And there's another talk. I forgot about the company's name, but I think most of them is actually in the pipeline track. So just search for capture data or data capture in the topics, and you will find them.
Okay, and just don't forget, you have one more week to submit your talks to Kafka Summit,
New York and London.
Yes, are you submitting a talk?
Yes, I'm submitting one.
Can you share what about? Or
well, you are on the committee, so I will not say.
I'm not on the committee.
Oh, really? Okay.
Yeah, but okay, I get it that we want it to be a secret, but I'm crossing fingers that yours will get accepted. I'm actually not submitting one.
Oh.
I feel like I totally ran out of things to say. Okay. And now for the "you guys are doing a good job" segment. In the same video, installing and running KSQL from the Level Up Your KSQL series, Mohassin Ibrahim says, "This is just simply great." And I agree, KSQL is just simply great. And people do not stop raving about the Martin Fowler talk from London, which it's been a while, but I think it's just good explanation of the how to use Kafka with event-driven architectures, and it's something that a lot of people kind of struggling with as they get up to speed with event-driven architecture. So Vimal Krishna says, excellent talk, gave lots of input to understand event-based systems, and I can't help but agree that yes, and that does help a lot in understanding event-based systems. Okay, so that's it for today. We had good fun, great questions from the community as usual.
Yeah.
Thank you so much for helping to answer them.
And thank you for having me here.
I hope to have you here again. And this was the last episode of Ask Confluent for 2018. So we hope you had a great year with us in your job, in your life, and we're looking forward to see you again in 2019.